Good morning or good afternoon, grade 10. This is Mr. K just quickly going through your formative stoichiometry quiz in preparation for your test. So, to start off, the first question, 1A, find the relative molecular mass of aluminium sulfate. And that's Al2. Let me just pull up my Al2O3. So the key thing to remember for this is just the sum of, that's what that little symbol there means, sum of the ARs. And so aluminium is 27, that will be this number here. And we've got two aluminiums, so you have to have two aluminiums, so two lots of 27. And then we've got three sulfates. So I actually have SO4, SO4, and SO4. That's what this 3 here means, okay, that I've just scribbled out, this 3. So you've got to have 3 sulfur and 4, 8, 12 oxygen, okay? And I've simplified this by putting 32 plus 16 times 4, all of that times 3, okay? And that gives you a total MR of 342. This you're then going to use because for question B, how many moles are 200 grams of aluminium sulfate? Well, moles equals mass divided by MR. Hopefully you remember that equation. We have mass at the top of the triangle, moles and MR. Okay. And so this is going to be 200 grams. That's given to you in the question. And we're going to divide that by the MR. So that's the MR from the question before, and it's really just leading you in. So that number goes there. And that equals 0.58. If you got the answer to 1A wrong, then obviously B will be wrong, but you should get error carried forward marks as long as you substituted or did 200 divided by your answer from question A. Moving on to question 2A, the amount of calcium carbonate reacted in moles. So first of all, again, we're going to work out an MR. So the MR of calcium carbonate, this is 40 plus 12 for carbon, plus 16, plus 16, plus 16 for each of these 3, notice the 3 there, oxygen. Okay, all of these numbers are taken from the periodic table. So that gives you a value of 100 grams per mole, it would be the unit. And moles of calcium carbonate is we're just going to take that 20 grams. It's going to take that 20 grams and divide it by our MR, which you've just worked out, okay, and that should give you 0.2. Next question, B, the amount of HCl reacted in moles. Okay, so here the ratio is 1 to 2, in that we have just calculated the moles, so this is moles of CaCO3, and the ratio, if going to this equation, is a 1 to 2. 1 to 2. Okay, let's draw that in black pen so it's a little bit more obvious. 1 to 2, and then I will highlight again. Okay. So you need to take the moles of calcium carbonate, divide it by 1, and times it by 2. So just taking you back a little bit, I'm going to show you a blank space. If calcium carbonate is in a 1 to 2 ratio with, is it HCl? Yeah. What this is saying is this would be my bike frame. Okay, and these would be my wheels, and I need 2 wheels to 1 bike frame. Yeah, if you had 10 frames, I would need 20 bikes. Now you don't have 10 and 20. Instead, we're going to use the answer from before. So that was this one, 0.2. And we want to know how many of these. So I divide by my own coefficient. So that would be dividing by 1. And I times by the coefficient of the one I'm trying to find out. So that would, in this case, be 2. Okay, and this would then give you 0.4. So going back to our question, 0.2 times 2 equals 0.4 moles of HCl. The amount of H2O, question C, the amount of H2O produced in moles and grams. Well, this is a 1-to-1 ratio. If I take my 0.2 again, going back to my equation, that's a 1-to-1 with H2O. So H2O is also going to be 0.2 moles. And the mass, well, I just need to use my equation, mass equals moles times mR, now that we've rearranged it. And this would be 0.2 times 18. 18 is the mR of water. And that gives you 3.6 grams, as you can see in that green box. Next question, the amount of molecules of CO2 produced. And this, again, calcium carbonate to CO2 is a 1-to-1. So it's a 1-to-1 ratio, so it is also 0.02 moles of CO2. And this is asked for the amount of molecules, not the amount of moles, but the amount of molecules. So the physical number of things. Remember, moles represents a number, like a dozen. But moles isn't a dozen. 1 mole is 6.02 times 10 to the 23. It is Avogadro's number. So for CO2, we have to take 0.2 moles and times it by Avogadro's number, 6.02 times 10 to the 23. And that would give you 1.204 times 10 to the 23 molecules of CO2. Next question. The volume of CO2 produced in decimeters cubed. Now, so the common mistake here was to take the number of molecules and times that by 24. So from question D. But in actual fact, to work out the gas volume, you need the moles, and then you're going to times that by 24. So this would be 0.2 moles of CO2 times 24 would give you 4.8 decimeters cubed. Next question, question 3. When 2.92 grams of hydrated magnesium bromide was gently heated, 1.84 grams of anhydrous magnesium bromide, MgBr2, were left. Find the formula for the hydrated salt. So for this question, the first thing that you need to do is work out how much water there was. So this is the difference. This is the difference in the two masses. So the 2.92 includes the water, and the 1.84 is when the water has been removed. So 2.92 minus 1.84 will equal 1.08 grams, and that is of H2O that was removed. Then, now that you've got that mass, you can form a table that I have originally showed you. We want the anhydrous, we don't care about the hydrated mass at this point in time. So the anhydrous MgBr2, which is 1.84, and the water, and we're going to work out the ratio of these two to each other. So the mass of MgBr2 is 1.84, water was 1.08. If we divide by their MRs, so you had to work out the MRs, water is 18, and MgBr2, if you would be 24 plus 2 lots of 80, because bromine is 80, that would give you 184. So the final moles of MgBr2 would be 0.01, and the final moles of H2O would be 0.06. If you then divide by the lowest number of moles, this gives you a whole number ratio. But you can probably already work out the ratio based on just the moles. You can see that there's 0.06 water is 6 times as much as 0.01 magnesium bromide. Giving you the final formula of where X is represented by 6, so MgBr2 dot 6H2O. Thank you.